Friends, welcome to the 6th lecture in module 2, where we will talk about some innovative structural forms which are addressed as new generation platforms. Let us quickly understand that offshore structural design moved from fixed type to a floating type. Once we agree that this transformation is advantageous, as we know there are some difficulties in this. The foremost difficulty is the system is permitted to undergo large displacements. Now, this can be a demerit in sense when the platform undergoes large displacement in flexible degrees of freedom, this may cause inconvenience to operate. Sometimes it may even challenge the safety. Or I should say safe operability. So, then what we should do to address this problem? So, the issue is very simple. Deck or the hull is connected to supporting system which ensures a rigid body motion. In parallel, we also understand the taut mode teethers of TLP and deep draft cylinders of spar are good designs. We agree that because we saw the advantages of these points. So, now I want to capture this advantage into a new structural form. I want to maintain the structural form to remain flexible on certain degrees and remain rigid on certain degrees of freedom. At the same time, I want to control the large displacements. So, that is the motive now. New generation platforms address this problem. Let us see how. So, deep and ultra deep waters exploration demand various types of structures as tension leg platform, spar, semi submersible, FPSOs. In addition, a new concept was initiated in 2005 based on something called buoyant leg structures. A new concept was introduced by Charles et al. In 2005, which is based on buoyant leg structures. So, that becomes the basis of the design of the geometric form. Now, what are buoyant leg structures? Buoyant leg structures in simple terms are actually deep draft cylinders which resemble spar cylinder or spar buoy, which are not taut mode, because we know spar is on a taut mode system, but slack mode. They can be useful to sustain wave loads. Having said this, a new system by name Triceratops is conceptualized, which consists of a deck, 3 buoyant legs. Now, the deck and buoyant legs need to be connected. We connect these deck and buoyant leg using ball joints. So, this is my deck, maybe multi tire. This is one tire, middle tire and upper tire, supported by a truss system, and it will have all topside detail like a flare boom, like a drilling derrick, like an helipad, like living quarters. Now, the buoyant legs which will have a deep draft, this is my water level, should be now connected further to the seabed. So, the seabed is connected to the tether, to the buoyant legs with initial pretension tethers. These are either called tendons or tethers, which has very high initial pretension. Now, friends, let us recollect some important facts what we studied about TLP and spar. A deep draft cylinder like a spar is advantageous. A tension leg taut mode system like a TLP is advantageous. These two advantages are combined to form a Triceratops. So, Triceratops is conceptualized by supporting a deck by a buoyant leg, which is further anchored to the seabed using tethers. Now, the buoyant legs and deck are connected by ball joints. Now, this ball joints is an innovative element in Triceratops. What exactly it does? Very interestingly, these ball joints have a special function. Let us see what is the special function. We already know large displacements are not desirable. They are not desirable. Now, let me ask you a question, where these large displacements will occur? Where they will occur? It is expected they will occur on the deck. So, large displacements on the deck is not desirable. So, what we should do with the ball joint is, the ball joint should be able to restrain large displacements. The moment I say large displacements, what kind of displacements are harmful? Usually rotations, they are undesirable. So, friends, ball joints are designed to restrain transfer of rotations from buoyant legs to the deck, but transfers translational degrees or displacements. So, I should say now deck is partially isolated from the buoyant legs. So, that is a very important advantage which makes this platform as a new generation platform. So, when we do analysis, we must account for these degrees of freedom. So, let us say what would be the degrees of freedom we will have for the system. Let us take this system. The buoyant legs will undergo all 6 degrees of freedom, which will be surge, sway, heave, roll, pitch and yaw, out of which roll, pitch and yaw will not be transferred to the deck. So, the deck will have only 3 degrees of freedom, namely surge, sway and heave. So, 3 rotational degrees of freedom will not be transferred to the deck. So, in total the system will have 9 degrees of freedom, 6 for the buoyant legs and 3 for the deck. So, the system will have different degrees of freedom for the deck and the buoyant legs, which we must account in our analysis. So, conceptually Charles et al. 2005 stated that Triceratops are advantageous and adaptable to ultra deep waters. So, that is a conceptual figure which was a new geometry tried and attempted. You can see here this is the deck which contains all details as that of a conventional platform. All these 3 are buoyant legs, these are teethers which have very high initial pretension, and these are the ball joints which connect the teethers the buoyant legs to that of the deck. So, what are the characteristic advantages we have in this structural form? We can say it has got better motion characteristics because the deck or the hull is partially isolated from the buoyant legs, that is an advantage. Secondly, it is a simple geometry. Thirdly, it requires a very simple station keeping, it does not require a complicated dynamic positioning system etc., does not require. You can see from the concept itself, it is easy to install and commission, it can be easily reusable and relocated. It is called a simple restraining system because studies show that the T0 value of that of a Triceratops is far lesser than T0 of a tension leg platform, because by design TLP has buoyancy exceeds the weight, whereas in Triceratops this is partially taken care of by the connection. So, the initial pretension in teethers are far lesser compared to that of a TLP. So, that is an advantage, and therefore, all this will make Triceratops as cost effective for ultra deep waters.